Stand by for the time mark. T minus 35 minutes and counting.
சொல்லுங்க சார். அட்டை பெட்டி இருக்கு, அது கிழிச்சிடுவா. சரி சரி, இப்போ ஒர்க் அவுட் ஆகலையே, அதை வச்சுக்கூடா. சரி பார்க்குறேன், நான் கிழிச்சிடுறேன்.
TC SHAR 1 and 2.
Go ahead.
We observe both telemetry carriers are on.
Copied.
All stations Stand by for the time mark. T minus 30 minutes and counting.
Autonomous to CDP, Autonomous confirms range real-time network readiness for PSLV C-57 Aditya L1 mission launch.
CDP Roger.
Met to ROD and Mission Director. Benign weather conditions are prevailing for PSLV C-57 launch.
ROD Roger.
Calling P1, switch on the pulsars.
नमस्कार, एक बार फिर स्वागत है आप सभी दर्शकों का। मैं विकास स्वर्णकार यहाँ श्रीहरिकोटा के मिशन नियंत्रण कक्ष से इस मिशन की समीक्षा प्रस्तुत करूंगा और मेरे साथ हैं इंग्लिश कमेंटेटर मिस माधुरी पी। सबसे पहले आप सभी दर्शकों को हार्दिक शुभकामनाएं और बधाइयां चंद्रयान-3 मिशन की, जिसने पूर्ण सफलता के साथ 23 अगस्त 2023 को चंद्रमा की सतह पर लैंडर की सकुशल लैंडिंग की और इसके बाद रोवर ने पृथ्वी से 3,80,000 किलोमीटर दूर चंद्रमा पर विचरण कर भारत की अमिट छाप छोड़ दी है। इसके साथ ही भारत चंद्रमा के दक्षिणी ध्रुव पर सकुशल उतरने वाला विश्व का पहला देश बन चुका है। यह सब संभव हो पाया है इसरो के कुशल मार्गदर्शन और वैज्ञानिकों के अथक प्रयास से, लेकिन ये तो सिर्फ शुरुआत है। चंद्रमा अब इसरो तेजोमय सूर्य के अध्ययन के प्रयोजन से आदित्य L1 नामक अंतरिक्ष यान को आज 2 सितंबर 2023 को श्रीहरिकोटा के द्वितीय प्रमोचन मंच से भारतीय मानक समय के अनुसार सुबह 11:50 पर PSLV C-57 रॉकेट द्वारा प्रमोचित करेगा। आइए चलें सूर्य की ओर और विज्ञान के कुछ और रहस्यों से पर्दा उठाने और वैज्ञानिक तकनीक का प्रदर्शन करने। तो बने रहिए हमारे साथ आज के इस मिशन में, जिसका नाम है PSLV C-57 आदित्य L1 मिशन।
MC to CDP and control real-time programs loaded.
Namaste viewers. The Indian Space Research Organization is gearing for its rendezvous with the Sun.
R2 pulsar on.
To take you along on the live telecast of this momentous event today, I am Madhuri, giving the commentary in English.
P4 MOTR, you can switch
With
on the
me
radio.
is my co-commentator, Shri Vikas Swarnkar, who will be giving the commentary in Hindi.
Copied.
We are about to script yet another chapter in the glorious space research history of India. Today, the workhorse rocket PSLV C-57 will carry Aditya L1, the solar observatory of India, to be placed at a vantage point from where it will be able to continuously observe the sun and while being in the visibility of Earth-based ground stations. 10 days ago, India became the first country in the world to safely land a spacecraft in the South Polar regions on the moon. I'm sure many of you were the eager and proud spectators of the Chandrayaan-3 landing that was being telecast from ISRO, situated in Bengaluru.
Roger.
We bring to you an integration film for the PSLV C-57 that took place in Satish Dhawan Space Center, Shar, Sriharikota.
अभी आप अपने स्क्रीन पर देख रहे हैं, यह है प्रथम कोर चरण S-139 बूस्टर का नोजल एंड सेगमेंट। इस प्रथम चरण के साथ ये शुरुआत होती है और यह मिडिल सेगमेंट को इसके ऊपर संयोजित किया जा रहा है। ऐसे 3 मिडिल सेगमेंट इसके ऊपर संयोजित किए जाएंगे और अंत में हेड एंड सेगमेंट सबसे ऊपर की ओर संयोजित किया जाएगा और इस तरह तैयार होता है PSLV का प्रथम चरण कोर बूस्टर S-139। इसमें 139 टन का प्रणोदक होता है और यह इग्नाइटर है जो इसे प्रज्वलित करता है। इस मिशन पे यह है PSLV C-57 एक्सेल मिशन। तो इसमें हैं 6 स्ट्रेपॉन बूस्टर्स, हर एक में 12 टन के नोदक भरे जाते हैं। यह सब ठोस नोदक पर आधारित हैं। यह SI-TVC टैंक को उठाकर इसके साथ संयोजित किया जा रहा है। इंटर स्टेज आप देख रहे हैं, इसमें रिट्रो मोटर्स लगे हुए हैं पृथक्कन के लिए। और यह है द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है। इसमें विकास इंजन लगा हुआ है
All stations.
And here is the
standby
second
for the time
stage
mark.
of the PSLV rocket,
T-minus
prepared in
25
the
minutes and
subsystem
counting.
preparation facility and brought to the vehicle assembly building of the second launch pad to be integrated on the first stage of the rocket. Here you can see the third stage PS3 and PS4 being moduled
Roger.
and placed inside the respective shroud and then handled together
Roger.
to be moved to the vehicle assembly building.
ये नज़ारा आप देख रहे हैं व्हीकल असेंबली बिल्डिंग का, जहां पर पूरे व्हीकल को असेंबल किया जाता है.
These are the visuals from the clean room of the spacecraft preparation facility. This is the Aditya L1 spacecraft being prepared and ensconced into a protective container where the environment is controlled and the temperature is controlled, the cleanliness is controlled. At the vehicle assembly building, again, there is a clean room provision to safely integrate it to the rocket, and then the heat shield halves are closed. Now the vehicle is fully ready to be moved to the launch pad, which is about 900 meters away. This is PSLV C-57 standing majestically.
अभी अभी आपने देखा PSLV C-57 का इंटीग्रेशन वीडियो. यह पूरी तरह तैयार और कुछ अंतिम गतिविधियां जारी हैं, अंतिम जांच जारी हैं प्रमोशन से पहले की.
We are bringing this telecast to you live from the Mission Control Center at Satish Dhawan Space Center, Shar, Sriharikota. The launch will take place today,
23 minutes and counting.
the 2nd of September 2023 at 11:50 hours in time from
Control
the
to
second
all
launch
stations.
pad.
All stations switch over to channel 2 at T
The
minus
PSLV
20 minutes.
C-57 in
No
its
confirmation
XL
is
version
needed
will
to
carry
control.
Aditya L1 spacecraft having a mass of 1,480 kilograms. The mission intends to place the spacecraft in 235 by 19,500 kilometers orbit with an inclination of 19.2 degrees. The total mission duration will be 3,799 seconds or 63 minutes 19 seconds. Apart from Doordarshan, you can watch the live telecast on ISRO website,
Roger.
YouTube, Facebook and Twitter.
अब हम प्रमोशन से 22 मिनट की दूरी पर हैं. आदित्य L1 सूर्य का अध्ययन करने वाला पहला अंतरिक्ष आधारित भारतीय मिशन है. इस मिशन से आदित्य L1 नामक अंतरिक्ष यान को सूर्य पृथ्वी प्रणाली में लैग्रेंज 1 पॉइंट के चारों ओर एक प्रभामंडल कक्षा में स्थापित किया जाएगा. यह लैग्रेंज पॉइंट पृथ्वी से लगभग 15 लाख किलोमीटर दूर है. इस तरह L1 पर रखे गए उपग्रह को सूर्य को बिना किसी आच्छादन या ग्रहण के
Control to all
लगातार
stations.
देखा जा
Switch
सकता
over
है.
to channel 2 at T minus 20 minutes. No confirmation is needed.
यह अंतरिक्ष यान विद्युत चुंबकीय और कण चुंबकीय क्षेत्र सूचकांकों का उपयोग करके फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के सबसे बाहरी परत, जिसे हम कोरोना के नाम से जानते हैं, इनका निरीक्षण करने के लिए इसमें 7 निदभार लगे हुए हैं. इनमें से 4 निदभार सीधे सूर्य की गतिकी का अध्ययन करेंगे तथा अन्य 3 निदभार L1 बिंदु पर कणों और क्षेत्रों का यथास्थिति अध्ययन करेंगे. इस तरह आदित्य L1 उपग्रह के निदभार कोरोनल तापन, कोरोनल मास इजेक्शन, प्री फ्लेयर और फ्लेयर गतिविधियों और उनकी विशेषताओं और अंतरिक्ष मौसम की गतिशीलता को समझने के लिए अत्यधिक महत्वपूर्ण जानकारी प्रदान करेंगे. अब आपके सामने प्रस्तुत है आदित्य L1 कर्टेन रेजर.
The PSLV C-57 is prepared to launch the 1,480 kg Aditya L1 spacecraft into Earth-bound orbit, from which it will be placed into a halo orbit around the L1 point in 4 months. The satellite is intended to study the Sun and how it impacts the halosphere. The Sun, which is the center of our solar system and has always fascinated humans, is a ball of hot gases formed by the nuclear fusion process. The visible outer surface of the Sun is known as the photosphere, followed by the chromosphere and then the corona. After initially dropping through the chromosphere, the Sun's temperature abruptly rises in the corona, reaching extremely high values of 1 to 3 million Kelvin. The Aditya L1 mission has 7 scientific payloads to conduct a comprehensive study of the Sun. The Visible Emission Line Coronagraph, VELC, investigates the solar corona and the dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope, SOOT payload, scans the solar disk in near ultraviolet light and detects fluctuations in solar irradiance. The Aditya Solar Wind Particle Experiment, ASPECS, and Plasma Analyzer Package for Aditya PAPA payloads investigate the solar wind and energetic ions, as well as their energy distributions. The Solar Low Energy X-ray Spectrometer, SOLEXIS, and the High Energy L1 Orbiting X-ray Spectrometer, HELIOS, analyze X-ray flares from the Sun over a wide energy range. The magnetometer payload is designed to measure the interplanetary magnetic field at the L1 point. Aditya L1 is equipped to take in situ measurements of charged particles and fields at L1 and is dedicated to studying the Sun across several energy bands. The Lagrange point L1 is located around 1.5 million kilometers from the Earth, between the Sun and the Earth.
18 minutes and counting.
These observations are best made from a vantage point that provides a continuous view of the Sun. All payloads are designed in close coordination with ISRO centers and national laboratories like as IIA, IUCAA and PRL. With this mission, ISRO will once again demonstrate its position in space exploration.
We are 17 minutes 23 seconds from the launch time. The countdown for PSLV C-57 Aditya L1 mission has been 24 hours long. It had started yesterday. During the countdown, critical activities have been carried out on the launch vehicle and the spacecraft. The propellant have been serviced into the launch vehicle stages. The bottles storing the gases for command and control operations have been charged to pre-launch pressure levels. The onboard batteries have been charged.
Confirmed external hold mode.
Now in a little while we'll go to the automatic launch sequence initiation, for which the preparations are underway in the launch and mission control centers.
ROD to Mission Director. Range is ready for PSLV C-57 Aditya L1 mission.
Mission Director Roger. TTC Director to Mission Director. All TTC Director confirms readiness of all ISRO stations and network for supporting
अभी आपने सुना
C-57 Aditya L1 mission.
Mission Director Roger.
उपग्रह निदेशक,
TCTC,
रेंज निदेशक,
data lovers of planet,
टेलीमेट्री
Short 1,
टेलीकमांड
Short 2
निदेशक
station.
तथा यान निदेशक
TCTC
ने
corporate.
अपने तंत्रों की सूचना मिशन निदेशक को दे दी है। इसके पश्चात
T-16 minutes and
सभी
counting.
आंकड़े संतोषजनक होने पर
Mission Director, Mission Readiness Review and Launch Authorization Board have already given clearance for proceeding with the countdown and launch of PSLV C-57 Aditya L1 mission. All operations in the countdown sequence till automatic launch sequence have been completed satisfactorily. Based on the clearance obtained from launch vehicle, spacecraft, range and distract network stations and prevailing favorable weather conditions, Mission Director hereby authorizes to initiate launch operation sequence for the launch of PSLV C-57 Aditya L1 mission at 11:50 hours IST today, that is 2nd September 2023.
All stations to note, Mission Director has given authorization for the launch of PSLV C-57 Aditya L1 mission.
SDS servers activated. MC
अभी
confirms
आपने
data
देखा
from SHAR-1
इस
and
मिशन
SHAR-2.
के मिशन डायरेक्टर श्री
T-minus
एस आर
15
बीजू
minutes
ने
and counting.
इस मिशन का
Hereby authorizes us to initiate automatic launch sequence for the launch of PSLV C-57 Aditya L1 mission.
Automatic launch sequence initiated for PSLV C-57 Aditya L1 mission.
The automatic launch sequence, the initiation has been announced, and hereafter a very critical capsule of performance validation for the launch vehicle systems will be carried out, and very close to the launch time, control will be passed on to the onboard computers.
जी हाँ, ऑटोमेटिक लॉन्च सीक्वेंस चालू हो चुका है। ALS शुरू होने के पश्चात रॉकेट स्वचालित होकर सर्वप्रथम T-0.3 सेकेंड्स पर RCT का प्रज्वलन शुरू करेगा और T0 पर कोर बूस्टर S139 का प्रज्वलन शुरू होगा। लेकिन इस दौरान वह स्वचालित तरीके से सभी जांच जारी रखे हुए है।
PS2 control system rotary chain actuation in progress.
On your TV screens, Honorable Minister of State for Science and Technology and Prime Minister's Office, Dr. Jitendra Singh. This mission is the 91st launch mission of ISRO and 59th of Workhorse PSLV. As mentioned earlier, PSLV's XL version with 6 strap-on motors alongside the core S139 motor is being used for the present mission. This is the 25th time PSLV XL is getting ready for launch. So far in the year 2023, ISRO has launched SSLV's maiden successful mission, 2 commercial missions of PSLV, 1 mission of GSLV carrying the first among the second generation of navigation satellites, 1 commercial mission of LVM-3 and another mission of LVM-3 again, carrying the prestigious Chandrayaan-3's spacecraft.
PS4 control system actuation in progress.
आदित्य L1 जो कि एक अंतरिक्षयान है इस मिशन का, इसको पृथ्वी से 235 बाई 19,500 किलोमीटर की निम्न भूकक्षा में 19.2 डिग्री के झुकाव के साथ अंतक्षेपित किया जाएगा। इस कक्षा में निर्धारित आर्ग्यूमेंट ऑफ पेरिजी 346.6 डिग्री को प्राप्त करने के लिए PSLV के चतुर्थ चरण को 2 बार प्रज्वलित कर इसे प्राप्त किया जाएगा। आर्ग्यूमेंट ऑफ पेरिजी असेंडिंग मोड और पेरिजी के बीच के कोण है जिसे कक्षीय तल के साथ मापा जाता है। आदित्य L1 के इस दीर्घाकार कक्षा में अंतक्षेपण के पश्चात उचित समय पर और उचित अभिवृत्ति में अंतरिक्षयान में लगे लिक्विड एपोजी मोटर्स को फायर कर कक्षांतरण किया जाएगा और इस तरह 5वीं बार में LAM मोटर को फायर कर यान को पृथ्वी की प्रभावी क्षेत्र से बाहर निकलने में समुचित गति प्राप्त की जाएगी। फिर वह पृथ्वी की कक्षा से छोड़कर सूर्य की कक्षा में प्रवेश करेगा और ऐसा करते हुए यह करीब 125 दिनों का समय लगेगा। 125 दिनों बाद यह L1 पॉइंट के पास पहुंचकर और उसकी परिक्रमा करना शुरू कर देगा और यही वह L1 पॉइंट है जहां पर से यह अपने वैज्ञानिक उद्देश्यों का भी प्रतिपादन करेगा। अब हम उड़ान से 11 मिनट की दूरी पर
control system actuation in progress.
Let me in the meantime tell the viewers about the flight events that the launch of PSLV C-57 Aditya L1 will take. This mission is among the longest flights of PSLV. It is going to last for 63 minutes and 19 seconds. The liftoff coincides with the ignition of core S139 solid rocket motor and the ignition of the 4 ground-lit strap-ons. While the rocket is at 2.7 kilometers altitude, the 2 air-lit strap-ons also commence their operation. The action time of strap-on motors is 70 seconds and the ground-lit and air-lit strap-ons are separated from the ongoing launch vehicle at 70 and 92 seconds into the flight, respectively. The core S139 motor continues to thrust till 110 seconds. Since the second stage of
10 minutes and
PSLV operates on pressure-fed liquid engine, the optimal performance of the engine is ensured if the effect thrust cutoff or separation of the lower stage is countered by additional means of thrust generation. Therefore, the alleged motors provided for this purpose ignite 3 seconds before the first stage separation and continue to thrust for 11 seconds. The second
Control
stage,
system activated
PS2,
of all
commences
stages
its
completed.
operation 200 milliseconds after the separation of first stage. By this time, the rocket would have attained 55 kilometers altitude. The closed loop guidance is initiated, which compares the present state of rocket to the intended injection point to compute an optimal trajectory. This happens while the rocket is at 59.7 kilometers altitude. At 204 seconds into the flight, the payload fairing is separated as the launch vehicle attains 113 kilometers altitude
T-minus
and the
9
dense
minutes and
atmosphere is no longer present around. These events are taking place in the operational regime of the second stage, which lasts for 153 seconds. PS2 is separated 262.4 seconds into the flight at an altitude of 130 kilometers, while the relative velocity is 4.9 kilometers per second. The third stage, PS3, ignites about a second later and burns for 118 seconds, during which time it adds 12 kilometers to the altitude and enhances relative velocity tremendously from 4.9 kilometers per second to 7.3 kilometers per second. There is a coast phase of 200 seconds that follow PS3 burnout, during which there is no thrust being developed, but the rocket continues to be steered. At 581 seconds into the flight, the PS3 separates, and the last and the
T-minus
fourth
8 minutes
stage
and
of
counting.
the rocket, together with the Aditya L1 spacecraft, coasts for a long time thereafter. Till 1396 seconds into flight, the tracking stations at Shar, Port Blair, Brunei and back will be acquiring the real-time performance data of the flight. But thereafter there is no visibility period of around 1600 seconds or 27 minutes. The fourth stage burns twice. First time for a duration of 30 seconds and second time for a duration of 472 seconds. The first burn takes place in no visibility zone and the second burn is tracked by a shipborne terminal placed in Pacific Ocean. About 200 seconds after the completion of second burn of PS4, the injection conditions for the separation of Aditya L1 are expected to be achieved. An altitude of 648.7 kilometers
T-minus 7 minutes
and a
counting.
relative velocity of 8.9 kilometers per second, which translates into an orbit of 235 by 19,500 kilometers. The injection event of Aditya L1 will be confirmed by tracking station at Kourou. From the initial placement in low Earth orbit, Aditya L1 will undergo a series of earthbound orbit raising and eventually it will exit Earth's sphere of influence to reach Lagrange's point L1 in a journey spanning over 4 months. There it will be placed in a halo orbit around L1. This is how India's first observatory class space-based solar mission will take shape.
Vehicle is in internal battery power.
अब हम उड़ान से 6 मिनट की दूरी पर हैं। ALS जारी है। सभी
T-minus 6
जांच
minutes
सुचारू
and
रूप से
counting.
जारी हैं। इस दौरान यहाँ उपस्थित आप देखिए, यहाँ
External power supplies are withdrawn.
व्यूअर्स गैलरी पे, लॉन्च व्यू गैलरी पे उपस्थित जन आक्रोश, इनका रोमांच देखते ही बनता है। इतनी
Flight coefficient loading
मौसम
initiated.
यहाँ लगभग 37 डिग्री का टेम्परेचर है, वायु गति 0.8 मीटर पर सेकेंड। इन सब के बावजूद यहाँ
Flight loading
उपस्थित हुए
completed.
हैं इस रोमांच को देखने के लिए। एयर ट्रैफिक कंट्रोलर और मौसम विभाग की अनुमति भी प्राप्त की जा चुकी है। विभिन्न ऊंचाई पर वायु गति माप ली गई है और इसे ऑनबोर्ड कंप्यूटर पर लोड कर दिया गया है।
The Satish Dhawan Space Center has its own meteorology department which keeps a very close watch on the weather at the launch base. Weather today is going to be dry and hot. The skies will remain clear. Ground winds will be benign and upper winds also are benign for the flight of PSLV C-57 Aditya L1 mission. We are 4 minutes, 23 seconds to the launch.
सभी वैज्ञानिक अपने कंसोल पर आंकड़े देखते हुए सभी तंत्र सामान्य निष्पादन कर रहे हैं। अब हम 4 मिनट की दूरी पर हैं उड़ान से।
T-4 minutes and counting.
सामान्यतः PSLV के मिशन लगभग 2000 सेकेंड में प्राप्त कर लिए जाते हैं, लेकिन यह मिशन कुछ अलग है। इस मिशन में PSLV के चतुर्थ चरण यानी PS4 को 2 बार में प्रज्वलित कर यह उद्दिष्ट कक्षा प्राप्त की जाएगी। इसका मतलब PS4 को प्रथम कोस्टिंग फेज के बाद प्रज्वलित किया जाएगा, फिर 30 सेकेंड प्रज्वलित रहकर यह बंद हो जाएगा, फिर करीब 1600 सेकेंड की कोस्टिंग फेज जारी रहेगी। तत्पश्चात फिर से PS4 को प्रज्वलित कर 472 सेकेंड तक प्रणोद उत्पन्न किया जाएगा और फिर शांत हो जाएगा। आदित्य L1 के कक्षा की स्थिति प्राप्त होते ही उसे निर्दिष्ट कक्षा में अंतक्षेपित किया जाएगा। इस तरह पूरे मिशन में लगभग 3800 सेकेंड का समय लगेगा।
T-3 minutes and counting.
यह PSLV C-57 का प्रमोशन यान ट्रैकिंग के संदर्भ में भी काफ़ी जटिल है। इसे ट्रैक करने के लिए शॉर, पोर्ट ब्लेयर, ब्रूने और बैग स्थित ग्राउंड स्टेशन हमें वास्तविक समय पे यान की जानकारी उपलब्ध कराते रहेंगे। लेकिन चतुर्थ चरण के प्रज्वलन के समय यान हमारे ग्राउंड स्टेशन की दृष्टि से दूर जा चुका होगा, इसलिए शिपबॉर्न ट्रैकिंग या शिपबॉर्न टर्मिनल को दक्षिणी पैसिफिक महासागर में स्थित किया गया है। वह हमें PS4 बर्न 1 और बर्न 2 की जानकारी उपलब्ध कराएगा। इसके बाद PS4 शट ऑफ और आदित्य L1 के अंतक्षेपण की पुष्टि कुरु फ्रेंच गयाना स्थित ग्राउंड स्टेशन से की जाएगी।
T-2 minutes and counting.
अब हम उड़ान से 1 मिनट 50 सेकंड की दूरी पर। यह PSLV की 59वीं उड़ान होगी और इस PSLV एक्सेल संस्करण में यह 25वीं उड़ान है। इसरो के वर्क हॉर्स कहे जाने वाले इस रॉकेट कई ऐतिहासिक मिशन को सफलतापूर्वक संपन्न किया है, जिसमें चंद्रयान-1 और मार्स ऑर्बिटर मिशन उल्लेखनीय हैं। यह प्रमोशन वर्ष 2023 का 7वां मिशन होगा। इस साल की शुरुआत में SSLV के सफल प्रमोशन से शुरुआत कर LVM-3 के 2 प्रमोशन, GSLV Mark II का 1 और PSLV के 2 सफल प्रमोशन हो चुके हैं। यह PSLV का वर्तमान वर्ष में 3रा मिशन है।
All stations stand by for the time mark. T-1 minute and counting. -55 seconds.
All subs are armed.
-50 seconds.
All sequencers armed.
तो हमारे साथ बने रहिए। अब 40 सेकंड पर
-40 seconds.
प्रमोशन किया जाएगा।
HPP open.
-35 seconds. -30 seconds.
Real-time programs activated.
-25 seconds.
PS2 VSPP open.
-20 seconds.
PS1 ignition RMS arm.
-15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
P3 tracking.
Magnificent liftoff of PSLV C-57 with Aditya L1 on board.
Plus 15 seconds.
PSLV C-57 का सफल उत्थापन और इसके साथ प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने।
Air lead strap on ignited.
इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C-57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky. A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill, are just amazing. Ground-lit and air-lit strap-ons operating together with the first stage, S-139.
Ground lead strap on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा।
Air lead strap on separated.
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground-lit and air-lit strap-ons have been separated. S-139 motor still thrusting.
S-139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
Plus 2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है।
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated, second stage has begun its operation, and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
Shar and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
Plus 3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Payload fairing separated.
The payload fairing covering the Aditya L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे यान से पृथक कर दिया जाता है।
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Second stage separated, third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन काल समाप्त होने पर और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है इसका प्रज्वलन शुरू हो चुका है।
We are close to 5 minutes past the launch time. Presently, The third stage of PSLV is operational, developing nominal thrust.
Plus 5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है और इसका प्रज्वलन काल 117.7 सेकंड का होगा। इस दौरान यह 240 किलोन्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का, वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV C57 का।
For the present mission, after PS3 completes its burn duration, a coast phase of 200 seconds will follow, in which the rocket will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में PS3 का प्रज्वलन काल समाप्त हो चुका है और कोस्टिंग फेज इसके बाद जारी रहेगा।
Vehicle in combined hosting for approximately 200 seconds.
Unique to this mission, the
Vehicle
PS4
performance normal.
will start twice at pre-designated times
Plus
and
7
duration.
minutes.
The multiple start capability of PS4 will be utilized very aptly to achieve the argument of perigee of 346.6 degrees, which is very crucial for this mission. The commencement and duration of PS4 burns enable achieving this orbital parameter. Argument of perigee is the angle that is made by the perigee point from the ascending node at equatorial plane. AOP exceeding 300 degrees is helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का, जो कि ग्राउंड स्टेशन द्वारा प्रसारित किए जा रहे हैं। वर्तमान में PS3 PS4 कंबाइंड कोस्टिंग फेज जारी है। यान की ऊंचाई 170 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है।
Vehicle performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya L1, describing the sun, Indian Vedas have said, Yesha Bhagavan Manirakasha Mandalasya Chakravarti Khechara Chakrasya Deepako Brahmanda Bhandasya Asayeva Charkarti Bharvati Jarhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth, the explosive phenomena in sun and the solar flares are a cause for concern to the spacecraft and human space missions. The vantage point for such observations is a place in between the sun and earth.
Third stage separated.
Now we have a successful separation event of the third stage of
Separated
PSLV.
hosting, it is approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक पृथक कर दिया गया है और अब PS4 कोस्टिंग फेज पर है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ जा रहा है।
We are 627 seconds from the launch. For another 600 more seconds or so, we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लैग्रेंज पॉइंट से जुड़ी कुछ रोचक तथ्य भी हैं, जैसे कि इस पॉइंट का नाम एक इटालियन फ्रेंच गणितज्ञ जोसेफ लुइग लैग्रेंज के सम्मान में रखा गया था। उन्होंने 1972 में इसे अपनी तकनीकी प्रपत्र जनरल 3 बॉडी प्रॉब्लम में वर्णित किया है, लेकिन इससे पहले भी 3 पॉइंट L1, L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ लेनार्ड आयलर को जाता है। L1 पॉइंट पर नासा ने पहले ही सोलर एंड हेलियोस्फेरिक ऑब्जर्वेटरी सोहो को पहुंचा चुका है और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप को L2 लैग्रेंज पॉइंट पर स्थापित किया गया है। L1 की पृथ्वी से सूर्य की दिशा में दूरी लगभग 15 लाख किलोमीटर है और इसे हम एस्ट्रोनॉमिकल यूनिट में 0.01 एस्ट्रोनॉमिकल यूनिट कह सकते हैं। यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun is a place in between the sun and earth where direct visibility exists to the sun while continuous communication link exists with the earth. These observations will generate a forewarning about disturbances in near earth space environment which could pose danger to the communication systems and spacecrafts. Various thermal and magnetic phenomena on the sun are of extreme nature, which cannot be replicated in labs. The best way is to observe the sun up close. The distance between the Earth and Sun is approximately 150 million kilometers. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 degrees Celsius. The Aditya L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1 or L1 of the Sun-Earth system, which is about 1.5 million kilometers from Earth, roughly 1% of the distance to Sun. A halo orbit is a periodic three-dimensional orbit near the Lagrange point in the three-body problem of orbital mechanism. The object in this orbit stays in place by the gravity of Earth and Sun. It requires little energy for station keeping. Several probes have been placed in space to observe the Sun by various space agencies. Lagrange's point L1 is a great location for solar explorers such as Aditya L1, as it allows for an unobstructed view of the Sun that is never eclipsed by Earth. At L1, Aditya L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य L1 उपग्रह को भी ऐसे ही लैग्रेंज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहाँ आदित्य L1 के बारे में बात कर रहे हैं, तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट 1 के पास जाएगा और यहाँ ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृत्ति नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृत्ति प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere, and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle, and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph (VELC), which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit, and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer, or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE, and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer, or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer, or MAG, developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में निधभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HE-L1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति नितभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्दिष्ट कक्षा की ओर बढ़ रहा है। आदित्य L1 के नितभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VELC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही URO सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लैबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लैबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India has made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hat. In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya L1 space mission. So today we are joined by Dr. Anil Bharatwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya L1 mission, Dr. Durgesh Tripathi, PI of SCYT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA,
Plus 25 minutes.
and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya L1 launch. To start with the principal scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya L1 mission so important and what are the objectives of this mission?
Thanks a lot. I mean, first of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And Sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor U.R. Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads, what was conceived for this particular mission, will provide a unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wavebands which are very important for the Earth ionospheric connections like near ultraviolet band, and the high energy particles, which is high energy radiations as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we move on to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya L1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya L1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction but also around it. Now when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth, and L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun in the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7, through using this mission, and this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So this instrument is very difficult to make, challenging, but it is made. Now it's going to the orbit. Now what we plan to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these holistically will give you a lot of information regarding not only the sun, but also the heliosphere. Thank you.
That was very interesting, Doctor. Thank you very much. And now we'll move on to Durgesh Tripathi, Dr. Durgesh Tripathi. You are the PI of the for the payload suit. How is that different from other telescopes like Hubble or James Webb? And what are you going to investigate using this?
Yeah, so good afternoon. My voice is going to mumble because I'm still in the awe of the launch, and one of the payload is gone there. So essentially, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, different objects, galaxies, star formation, and other objects you see in the universe. Whereas when we talk about Aditya L1, it is going to look at one particular object, which is our sun. And it's also kept on the other side of the Sun-Earth line at the L1 point, whereas the James Webb Telescope went on the other side of the Earth, which is at the L2 point. Now, the scientific difference, of course, they also observe in ultraviolet, but Aditya, as Professor Anil Bharadwaj and also Professor Anna Purnisubramanian alluded to, these are multi-wavelength satellite, and they will be observing all across the electromagnetic spectrum. In particular, suit is going to be looking at the ultraviolet radiation in 2000 to 4000 angstrom, if that matters to you, emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere is coupled by looking at the observations at various height, and how actually this radiation is coming and getting absorbed in the Earth's atmosphere, and what kind of effect it can have in the chemistry of ozone and oxygen, for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have. Thank you.
Thank you very much, sir. And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds, and how does it impact?
Thank you. Thank you for giving opportunity to come into this show. As my colleagues, they mentioned actually about the sun. Today we have the auspicious day where actually we are going to our own star, that is the sun. Just I want to tell to the viewers that actually the sun, which is our hero basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied by sun. And also this sun is plasma. Now, when we are talking about the heliosphere, actually with this, all our planets are engulfed in that thing. You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we are lacking actually a comprehensive approach, because sun is giving its energy mainly in three forms. The first one is the radiation, actually my colleagues already talked about, which we can do remotely from our ground. But the plasma, basically we are talking about the solar wind, what we call the space plasma, as well as the magnetic field. This can be only studied by in situ. If we study all these radiation, particles and field, then only we will get a full comprehensive understanding of the sun. Now, we are getting the first space-based observatory from the Indian soil, and we are making this opportunity. And of course, I am thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues here. This is the opportunity we got actually. We are trying to understand actually all the three things: radiation, particles, and field. Already they mentioned about the radiation. Now, Dr. Bivin will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means Plasma Analyzer Package for Aditya. This is developed by Space Physics Laboratory in support of Vikram Sarabhai Space Center. And now this instrument has two components. If you look at the solar wind, basically it comprises of 95% protons, then alpha particles roughly around 4 to 5%, then equal number of electrons also. So our PAPA is a comprehensive package measuring both ions and the electrons. Now these electrons, like already our colleagues they mentioned actually the major transition events like coronal mass ejection. That's a huge mass which is coming out of sun. Basically it's a plasma. Basically when we are talking about solar wind, basically nothing but it's the extension of the corona only. That's the atmosphere. Now these particles actually they only actually modulate the energy and momentum of the planetary atmospheres. See when then sun is quiet, like he is not aggressive, sun is what we are getting the ambient solar wind. So if you look into that thing actually, that one actually gives what we call about the interactions, what we call the normal routine phenomenon which is happening on there. But when there is sun is angry, it gives like in a CME, CAR or these sort of events are happening, that is really going to affect our planets. That's what we call the space weather. Now our intention is to understand first of all actually what these effects, basically the solar wind in the ambient condition as well as during this transition events, how this solar wind behaves, and also how this coronal mass ejections which is passing through different planets, how actually what are the different things like what we call about the microphysics, macrophysics and the mesophysics of that things that we want to understand. So one thing is actually it's a physics subjective to understand because we are getting an ideal point, Lagrangian point, which is in the sun-earth plane, and we will be seeing the events exactly there. Second thing is actually we can definitely monitor the parameters. Like what actually PAPA will measure electrons and ions, we will be getting energy, direction and angular information, mass information. So if we know these things related to electrons we don't want the mass, but for the ions we are getting the mass information. Coupling all this information actually what we can do is we can derive the plasma moments. That will be definitely going to the modeling part, actually dynamics part, and that will definitely going to tell about the effect of the space weather effects.
Yes.
So in due course actually with the L1 in addition to other L5 missions we will be able to tell. This is the importance of the plasma missions.
Yes.
That actually as you mentioned actually earlier with the lunar mission we tried to understand that thing. Really it changed, this plasma studies changed the perspective of the moon. Now Aditya will give more detail about it.
Yes.
Thank you.
Thank you, sir. Thank you so much for that, sir. And now we move on to Dr. Dipankar Banerjee. So you manage the beautiful solar observatory at Nainital. How do you think the studies of heliophysics will supplement Aditya L1? Can you tell us something about the history of solar observatories in India?
That's right. India has a long tradition of looking at the sun from the ground. In fact, from Kodaikanal Observatory, we have been observing the sun for more than 100 years. And also we have beautiful, solar observatory at Udaipur, in the lakeside, and at Nainital. We are looking at the sun. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. So this was very, very important that we could go to the space. And this is a fantastic opportunity. Originally, more than 10 years back, we were only looking at a small satellite program. And then Professor U.R. Rao suddenly came up with this idea, why are we taking baby steps? We should think big. We should go to much longer distance. And then this opportunity came in, the Lagrangian-1 mission. The entire country, all the scientific institution got very much highly motivated. There are multiple payloads were then proposed. So eventually now we have a Lagrangian-1 observatory class mission. And as you heard from my colleagues that it is a multi-wavelength observatory. So that's very important to have the shorter wavelength coverage from the space. And in addition, the ground-based observations are also important. So a combination of the ground-based telescope and the space-based platform is very, very important. And since you asked about the question about the, how Aditya in the overall heliophysics research within the international scenario, we only have 3 spacecraft around Lagrangian-1 point primarily from NASA and ESA. So I think again this is a fantastic achievement from India if you could reach L1. with the full observatory class mission, it will really open a new window altogether. So I think this is a great opportunity, and we are all looking forward. And as I mentioned, probably we'll request that, a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have a very nice ground-based telescope also to complement the capabilities of Aditya L1.
Thank you very much, sir. Indeed, it's a very great opportunity. And now we move on to Dr. Vipin K. Yadav. So you're in charge of the magnetometer. What is the contribution of magnetometer to Aditya program?
You see, the magnetic field measurements are very crucial in space, and especially at L1 point. What we are going to measure with magnetometer is the interplanetary magnetic field that is coming all the way from Sun and towards the Earth. So typically these values at L1 point are around 5 to 10 nanotesla. But these values increases whenever there is an extreme solar event, such as the coronal mass ejection or say a solar magnetic storms. Now these events are crucial to monitor the near Earth space weather, because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped a few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements, and apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres, and how does Aditya L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to 27 arcs to 10 to 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are two unique instruments built by URAO Satellite Center that is going to cover the solar flares from 1 kV to extremely high energy, around 200 kV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these two instruments, along with the other two instruments, VLC and SUIT, we are going to address this $1 million questions, as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya L1 absolutely unique, because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the ASPECTS payload, which stands for Aditya Solar and Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know, because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. And therefore, we should know in what direction the plasma is coming, and whether the plasma is getting accelerated in between when it comes from sun towards earth. And therefore, there is a multi-direction information which is available from the ASPECTS payload, because it consists of two sensors, SWIS and STEP, essentially giving you in two different energy bands, and therefore, we'll be able to quantify the CME, CIRs, and all the processes which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally we move on to the principal scientist, Dr. Sankar Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like Astrostat and Aditya L1?
Yeah, so now ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. And that is something which especially a heliophysics community could utilize it, because we can, at a low cost, we can launch many more such instruments which are essential for heliophysics community here in India. So, and also the bigger mission takes its own life cycle, because it requires technologies to be developed for a bigger missions. So in between these big missions, if we capitalize on these small satellite missions, and that will enhances the science capability of our country to the next level. And as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting. And to end this, I have a last question to Dr. Dipankar Banerjee. And it's about what kinds of outreach is possible through this launch to energize the scientific community?
This is a very, very important question, and we are proud to be Indian now after the Chandrayaan success. I think it's just not the students, it's the entire country is excited. And we got this opportunity to now travel towards Sun. So it is very important that the younger generation, comes into the research and also utilizes the data. These scientific missions are for the community, and it has to be the community driven. So some of our scientists, who have been engaged with this mission for decades, we understand what is expected to be, this data. But the younger generation, they need to be trained. And so for that reason, we also have a Aditya support cell at Nainital, and we are going around in the country. We are regularly conducting workshops. So through these workshops and training program, we really want to reach out to other, people who are particularly in the universities or IITs, because they have so far not been directly involved with the Aditya mission. So I think we are really, really going out, and we expect that the youngsters, that the next generation will come and utilize this data, because the data is for the community. So unless, we have more users, we will not be able to effectively utilize the data, scientific data which is coming, and the way we can help the community at large. Thank you.
Thank you very much, sir.
I think it is very important for us also to reach out to schools and colleges, because the younger generation should be told about this kind of activities which is happening in the country. Chandrayaan-3 launch has galvanized the whole nation, and everybody is interested to know what all is happening in the science and technology within the country. And therefore, this mission, along with the Chandrayaan-3 mission, that is the Aditya L1 mission and Chandrayaan-3 mission, is going to give us a lot of new information which is going to be very beneficial for the country. Thank you. Thank you very much.
Thank you everybody for participating in this discussion. And now we move on to the control room.
Thank you, Srinidhi. And I thank all the panelists for enlightening us about the high-tech science that Aditya L1 is about to do.
जी हाँ, अभी आपने सुना इसरो के तथा अन्य संस्थानों के वरिष्ठ वैज्ञानिकों ने हमारे बहुत महत्वपूर्ण सवालों के बहुत ही रोचक उत्तर दिए हैं। इस दौरान चतुर्थ चरण के बर्न 1 को कंफर्म किया गया है फिजी टेलीमेट्री स्थित स्टेशन से। इसमें यान में होने वाले त्वरण के बदलाव को मापा जाता है और इससे पता लगाया जाता है कि यान के इंजन में शुरुआत हुई थी या नहीं, और इसकी पुष्टि कर ली गई है। लेकिन अभी भी यान हमारे दृष्टि से बाहर है, हमारे ट्रैकिंग रेंज से बाहर है, लेकिन इसकी यात्रा अभी जारी है। और अब हम स्क्रीन पर देख पा रहे हैं यह पूर्वानुमानित पथ दिखाया जा रहा है। यह अनुमानित पथ है। ग्राउंड स्टेशन से पुष्टि होने के पश्चात यहाँ पर इसकी पुष्टि की जाएगी। आज 11:50 पर प्रमोचित हुए PSLV C-57 रॉकेट की यात्रा अभी भी जारी है। प्रथम, द्वितीय तथा तृतीय चरण के सामान्य कार्यकाल के पश्चात इन्हें यान से पृथक कर दिया गया था। और फिर
टर्मिनल acquires telemetry signal.
जी हाँ, इसकी पुष्टि हो गई है। शिपबोर्न टर्मिनल से हमारे यान को ट्रैक कर लिया गया है।
At present, ground trace and FPD are updated based on real-time data.
अब हमारे ग्राफ को वास्तविक समय से दिखाया जा रहा है। यह वास्तविक डेटा है जो अब हम देख पा रहे हैं।
Welcome back to the live coverage of PSLV C-57 Aditya L1 mission. The launch took place at 11:50 hours Indian Standard Time from the second launch pad at Satish Dhawan Space Center, Shar, Sriharikota. The first, second and third stage of the launch vehicle have performed normally, and the launch vehicle was in the no visibility range for the ground tracking stations. Shipborne terminal in Pacific Ocean has started to acquire signal 51 minutes into the flight.
अब कुछ ही क्षणों में हम चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Four-stage engine started for band 2.
यहाँ अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। यह वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं क्रूज स्टेशन से।
Very happy piece of news here.
Normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. Around 14 more minutes to go for the spacecraft injection.
जी हाँ, अभी भी लगभग 14 मिनट बाकी हैं हमारे अंतरिक्ष यान आदित्य L1 को अंतक्षेपण के लिए। आपकी जानकारी के लिए बता दें कि इस कालावधि जब अंतरिक्ष यान या हमारा यान हमारी दृष्टि से दूर हो जाता है, इस कालावधि में ग्राउंड स्टेशन की दृष्टि से बाहर जा चुका होता है और यान के ऑन बोर्ड कंप्यूटर पर टेलीमेट्री स्टोरेज पर यान के महत्वपूर्ण आंकड़े सेव किए जाते हैं। जब यह हमारे तय ग्राउंड स्टेशन की रेंज में आते हैं तब इन आंकड़ों का प्रसारण होता है और वहां से इनकी पुष्टि की जाती है कि यान इस दौरान किन गतिविधियों से गुजरा।
Fourth stage performance normal.
The fourth stage performing normally. The second burn is expected to last for 472 seconds.
यह चतुर्थ चरण है PSLV एक्सेल रॉकेट का। इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। इसमें 2 इंजन लगे होते हैं। हर एक 7.33 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
Plus 55 minutes.
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। वरिष्ठ गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds past the launch. PS4 stage currently burning for the second time.
Fourth stage performance normal.
Intended trajectory closely matching the prediction. Presently the shipborne terminal is acquiring the signal. Few seconds later there will be another no visibility phase before Koru starts to acquire signal.
जी अभी द्वितीय बर्न चालू है PS4 स्टेज का। अभी कुछ 200 और सेकेंड जलकर यह शांत हो जाएगा। सूर्य एक बड़ा और हमेशा से एक समीप का सितारा रहा है हमारे लिए। असल में यह गर्म आग का गोला है जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से ऊर्जा प्राप्त करता है और इस ऊर्जा से इस सौर मंडल को एक परिवार के भांति समेटे हुए है। पृथ्वी से सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। सूर्य ही हमारी ऊर्जा स्रोत है और इस जीवन जो हम जानते हैं उसका भी स्रोत है।
Loss of signal for shipborne terminal. The next telemetry station is Kuru. The telemetry signal break will be approximately 205 seconds. During this non-visibility period, ground trace and flight parameters will not be updated.
यान फिर से अंतर्दृष्टि हो चुका है, हमारे ट्रैकिंग रेंज से बाहर है। अगला ट्रैकिंग स्टेशन कुरू स्थित फ्रेंच गयाना स्थित कुरू स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में।
After being injected into the space, the Aditya L1 will not travel directly to the L1 point. Transfer maneuvers will be performed to position the spacecraft in a halo orbit. Aditya L1 will first be made to perform maneuvers in Earth orbit. Adjustments will be made in its orbital parameters. After ascertaining the normalcy of the craft, its systems, payloads, and the orbital parameters, burn to exit Earth's sphere of influence will be initiated. After exit from SOI, the cruise phase will start and subsequently the spacecraft will be injected into a large halo orbit along L1. The total travel time from launch to L1 will take about 4 months for Aditya L1.
इस दौरान आइए आपको अवगत करा दें आदित्य L1 के मुख्य उद्देश्य से। आदित्य L1 मिशन का मुख्य उद्देश्य है सौर गतिविधियों के विभिन्न पहलुओं में महत्वपूर्ण जानकारियां उपलब्ध कराना और इन गतिविधियों का अंतरिक्ष मौसम के असर का अध्ययन करना। इस कार्य के लिए इसमें 7 भार लगे हुए हैं जिनकी मदद से आदित्य L1 फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के बाहरी परत के विभिन्न वेवलेंथ में प्रेक्षण कर सकेगा। विशेष वैज्ञानिक उद्देश्य इस प्रकार हैं: सूर्य के ऊपरी परत जिसे हम कोरोना के नाम से जानते हैं, इसकी गतिकी का अध्ययन करना, क्रोमोस्फीयर और कोरोनल तापमान, आंशिक रूप से आयनिक प्लाज्मा की भौतिकी, कोरोनल मास इजेक्शन की शुरुआत और फ्लेयर्स का अध्ययन, सूर्य के कण की गतिशीलता के अध्ययन के लिए आंकड़े प्रदान करना और यथास्थिति कण और प्लाज्मा वातावरण के प्रेक्षण करना।
+1 hour.
वर्तमान में आरओडी ने घोषणा की अब चतुर्थ चरण को बंद कर दिया गया है, अब उसका थ्रस्ट कट ऑफ कर दिया गया है और वह बंद हो चुका है और इसकी भी पुष्टि हो चुकी है कि आदित्य L1 के अंतःक्षेपण की स्थितियां प्राप्त की जा चुकी हैं।
We are now eagerly awaiting the injection of the satellite as we have the confirmation from the Range Operations Director that the thrust cutoff for 4th stage of PSLV has been achieved. We are 1 hour into the flight.
कुछ ही क्षणों में क्रूज स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी।
Highly anticipated event next is the separation event of Aditya L1 spacecraft.
यान अपने निर्धारित कक्षा की ओर कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है। यान से अंतरिक्ष यान आदित्य L1 का सफलतापूर्ण अंतःक्षेपण अभी बाकी है।
For Aditya L1, ISRO has developed advanced flight dynamic software to obtain past trajectory data from tracking, apply mathematical computation to calculate present and future location of the spacecraft in a process known as orbit determination. But the correct orbital parameters at the time of injection are of prime importance.
अब तक कुल 22 सौर मिशनों को नासा, ईसा, जर्मन
Aditya L1 satellite separated.
और जिसका इंतजार था वह पल आ चुका है, इसकी पुष्टि कर दी गई है। आदित्य L1
mission accomplished, handing over to mission director.
And we have a confirmation of Aditya L1 separation. The mission has been accomplished.
PSLV C57 has injected Aditya L1 satellite into the desired intermediate orbit. PSLV C57 Aditya L1 mission is accomplished.
आदित्य L1 को पूर्ण परिशुद्धता से इसके निर्धारित कक्षा में स्थापित कर दिया गया है। इसके बाद वह अपने आगे की सफर जारी रखेगा L1 पॉइंट के लिए।
Do join us for the address by Chairman ISRO Secretary Department of Space, Shri S. Somnath.
सभी दर्शकों को शुभकामनाएं और बधाइयां इस मिशन की सफलता के लिए। अब हम आपको लिए चलते हैं अध्यक्ष महोदय के एड्रेसिंग के लिए।
Congratulations. The Aditya L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking 2 burn sequence for injecting the primary satellite for the first time. So I want to congratulate PSLV for such a very different mission approach today to do this mission of Aditya L1 to put it in the right orbit. Now, from now, the Aditya L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, a very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shahji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh. So I request him to speak a few words.
Congratulations, India. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
May I request the Project Director of Aditya L1, Nigar Shaji, to say a few words.
Good afternoon. It's a dream come true for Team Aditya L1, and I'm extremely happy that Aditya L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya L1 solar panels are deployed, and the spacecraft will be normal. And Aditya L1 has started its 125 days of long journey towards L1. We have our Earth burns to rise the orbit, and followed by the trans L1 injection, and finally insertion into the halo orbit in the Sun Earth Lagrange point L1. Once the Aditya is commissioned, it will be an asset to the heliophysics of the country and even to the global scientific fraternity. And I take this opportunity to thank Chairman ISRO, Director URSC, former Director URSC, and all the Center Directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbit insertion and further great science output from the Aditya L1 mission. Thank you all.
Sri Biju, the Mission Director and the Project Director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was indeed it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri M.J. Lal as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya L1 mission, just following the Chandrayaan-3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center. Thank you. Contribution from across the center, this could be done. So let me start with the Director VSSC.
Good afternoon, India. So this is the 59th mission of PSLV, and 1993 was the first mission. So this is the 30th year of PSLV. So it's PSLV is on the threshold of Shashti Purti. With the next launch, it will be making 60th launch. I wish all the very best to the satellite team, all payload specialists for the operation of the payloads and satellite in coming days. And I'm take this